Hello, everyone. Hope you're doing well today. And I'll echo the good morning, good afternoon, good evening, wherever you may be joining us. It was fun seeing in the chat beforehand where everybody's coming from as well too. And I also want to give a shout out to one participant here, Jen Cole, who's from my team, who helped organize and set up everything as well too. So everybody give a shout out to Jen as well too. So and with that, I'm going to share my screen and we'll get things started. Okay, and Othman, your comment already is fantastic. Happy Taco Tuesday, everyone. Yes, Taco Tuesday is the best. So what we're going to talk about today is going beyond the chatbot with event-driven agents. And I'm going to basically share a little bit of some experience and some experiments that I've been having lately with using agentic applications in kind of the non-standard ways and some of the things to think about, but also some of the opportunities that it presents itself. But with that, I want to start with a disclaimer that this isn't going to cover every aspect of creating a production-ready application, agentic app. At the end of the day, we're all still learning, we're all still experimenting, we're all still trying to figure out the space, et cetera. And so in many ways, like, view this as a inspirational talk, and here's some of the things I've been experimenting. Here's the things that I learned, both pros and cons. So if I were to do this again, how would I do things differently? But again, I'd love to get your experience, your thoughts, your ideas as well too. So as mentioned earlier, feel free to drop in chat questions along the way. If the question's related to what we're talking about, I'll go ahead and answer it then. Otherwise, we'll hold it towards the end. But again, we're all learning. So again, think of this as an inspirational talk. But again, we will talk about some of the Docker specific things that we're doing and build an agent live here as we go. Okay. So our agenda, what are we going to talk about? First, I'm going to spend some time and talk about the what and why of event-driven agents. What do I even mean by that? So let's put some definition to this. What do they look like, et cetera. And then I'm going to talk about a hackathon project that we had internally at Docker, in which I built a GitHub PR analyzer. And I'm going to talk about the problem space that was trying to address, and also how did I build it. And so we'll actually jump into code. We'll write the agent, write the application. We'll test it out, et cetera. And so you'll see that. And then we'll wrap up with what are lessons learned. And if I were to do this project again, how would I do things differently? And hopefully there's some takeaways for you yourself as you consider building some of these event-driven agents. With that, let's jump in. So what and why event-driven agents? So a little bit of background, and of course, I'm sure most of you already know at least this here. Okay, so generative AI is the hot topic these days. Okay, and at the end of the day, it provides the ability to leverage models to create new content based on a new set of inputs or prompts. So we train these models based on lots of additional data. All over the world, and maybe it's specialized data, whatever. And then we can give it prompts or inputs that it hasn't seen before to generate new content, whether that's text or models, or text or images, code, music, et cetera. But that's kind of what GenAI is all about. Now, taking that a step further, building agentic applications. Agentic applications use models, but then they also add additional capabilities. Okay, so they can go out and actually go and maybe reason and think, okay, I've got this goal. How do I get to that goal? What are the steps I need to take to get there? But then also, what are the tools that I need to leverage in order to get there? Maybe I need to go look up additional information or perform various actions, et cetera. So agentic applications pretty much need three things. They need the models, the brains, the reasoning, et cetera. They need tools to actually go and do stuff. And then there's the code that kind of glues it all together. Okay, and so as we build this agentic application today, again, look for these three different elements: the models, how are we choosing the different models; the tools, how are we hooking in the tools, and how are we running those tools safely and securely; and then finally the code, the agentic framework that we're going to use. Okay, but one of the important things here is if you look at these three requirements for an agentic application, a chat interface isn't the only interface. Okay, there's been many times in which somebody has sent me a link and said, "Hey, I built this agentic application, and it, is going to summarize GitHub issues and create a Notion page for me, whatever." Okay, and I say that's cool, and I launch it, and then I have to open up a chat interface to say, hey, can you summarize these things? It's like, uh, why do I have to use a chat bot in order to kick off this agentic flow? Isn't there some way that I can trigger this automatically or based on an event, or say, hey, every morning at 9 o'clock, run these tasks for me, and yeah, use agents, but then just go and do it. Like, why do I have to use a chat bot? So in many ways, again, one of my takeaways for this presentation is to get you thinking beyond the chatbot. What are other ways that we can build agentic applications with other ways of other forms of input? Okay, and actually, it wasn't that long ago that I had opened up my iPhone and Apple Intelligence was on it, and that kind of stuff, and I kind of had this epiphany where when I saw this is just a fake mock-up here, where I had a collection of group messages, and I had missed those messages, and I had noticed that the built-in models were summarizing the messages that I missed. Okay, so as an example, okay, this baseball parents group chat. Okay, there's a baseball game tomorrow from 6:45 to 8:15, and there's several confirmations. So even though there's been maybe 5 or 6 messages I've missed, there's this basically agentic application that's running in the background that's saying, hey, summarize all these messages, and then let's actually display that summary here. So now I know if I need to take action or if this is more of just a informational message and a bunch of confirmations. Okay. And again, to me, this was kind of one of those epiphanies, like, hey, this is using models, this is using agents, but in a way that I'm not actually opening up a chat bot and saying, hey, can you summarize all my messages that I missed? Okay. It's just doing it automatically. And as I thought about this, I was like, how would I recreate this? And so I was like, can I actually give models JSON data to actually play with? And I have a little sample application that I built for various training, and I'll switch over to that real quick. I call it the visual chatbot, and this visual chatbot lets me see the system prompt that I'm going to send to the model. Okay, so for this particular interaction, okay, you're a tool that's going to generate summaries for a collection of messages in a group chat, and here's the rules. The summary needs to be 200 characters in length, whatever. And so I'm going to give it a JSON block here that's basically, here's 3 messages. Okay, I need an FAQ for the website by the end of the day. Can you make that work? And then, 2 hours later, are you there? Any updates? And then finally, okay, never mind, we got it. We were able to use a Reddit post from the other day to build an FAQ. Okay, so let me add that to the stack here. And then let me send these messages to the model and say, hey, model, summarize this for me. And this is using a Gemma 3 model. And great, I got a summary here. FAQ needed by end of day, resolved, Reddit post used for it, no further action required. Okay, so again, I can build an application here that can craft these messages, send it off to the model, okay, get a response back, and now I can display this to the user, swap out you have 5 unread messages to now here's just a summary of what you've missed so far. Okay, so again, models are pretty versatile. In this case, working with JSON. And so as I continue to think about that, event-driven agents, the way I'm going to define them here are agentic applications that are triggered from external events. Okay, again, not a chat message. There's not a user typing in a chatbot. And so that event can be a wide variety of events. Okay, it can be a webhook. It can be a system event. Okay, maybe there was a file that was modified, or whatever other system event that you want to leverage. It could be time-based. Okay, at 9 o'clock every morning, go ahead and run this agent. Okay, so again, using events to then trigger applications that use models and tools to do something. Okay, so that's the context of what we're thinking about, what we're working with here. So now let's talk about this GitHub PR Analyzer. What is this? Okay, so at Docker, we had an internal hackathon where it was pretty open, and the goal was simply create an agent that automates something in your work life that will give you some time back. Okay, and as I got thinking about that, I'm like, man, there's a lot of different things I can do. But again, I wanted to try this event-driven agent approach. And what might that look like? So one of the things that on the DevRel team that we run into quite often is we have a lot of training apps, and we have sample apps. We have a lot of tutorials and workshops, and we just have a lot of this content out there, and they're scattered over a lot of different repositories. And yeah, we should probably we're constantly trying to do better with being a little bit more timely in responses to PRs and issues that are created with them. But again, there's a lot to work with there. Well, every so often we get PRs from students or from those that have completed the tutorials in which they submit a PR back to the repository to say, hey, here's the work that I completed while going through your tutorial. So, for example, here's one that's going to be about creating a Docker file and creating a container image. Here's the Docker file I made. And while we're excited that people are doing the tutorial, we can't accept that PR because it's going to inhibit the next person's ability to go through the tutorial. And so this is an example where during this particular tutorial, you have to update a website and you're using a containerized environment. And so they submitted that update. Well, again, I'm glad you did the tutorial, but it would be more, we can't accept that. Okay. And so then we write a PR conveying that excitement. Hey, we're glad that you're doing this. Keep up the energy and the excitement, et cetera. But unfortunately, we're gonna have to close this. And we get probably 5 of these a month. So it's not a huge amount, but again, it's something that we want to respond to quickly to show, hey, we're being responsive and encourage them to continue learning and growing, et cetera. So again, how can we be a little bit more timely and work with this? So this is the problem space that I was thinking about for this particular hackathon. How can we make an event-driven agent here to respond to these PRs to maybe determine, hey, is this PR actually providing the output of this tutorial? And if so, can we automatically just close it? Okay. So as I started building out the architecture of what this thing might look like, well, when a PR is open on GitHub, there are webhooks that can be triggered. Okay. So what if I were to take that webhook and register it and say, hey, let me create a webhook receiver that then, based on the PR that's open, let's analyze that PR. Let's take a look at it. What sort of files are being changed? What's the description of it, et cetera? Let's generate a comment if it's decided that we want to close this. Okay. And then let's actually post a comment and close the PR. Okay, so can we basically build a small little agentic application to do this? Now, in order for this to work, well, I probably want to give the analyzer the ability to go and look up additional details about the PR. And also the executor is going to have to be able to post the comment and close things. So these aren't just pure model, analysis and summary. They need to be able to go and do stuff. And so that's where tool calling comes in. And so I want to be able to give it access to GitHub MCP tools. Okay. And so if I can package all this together, then I can create an agent that's specifically tailored towards analyzing these PR. So I see a question already drop in chat. Can this be a code reviewer? Well, in many ways, this kind of is, but it's not analyzing for the intent of, hey, did you write the right code? Are there bugs with it? Is it following our guidelines? And you'll see this as we actually build out the agent. We're building this specifically to determine, is this PR something that we should auto close or not? Okay. And so I'll show how that plugs in here in just a minute. Okay. The automation flow here, again, kind of taking the previous diagram and just putting a little bit more into a flow chart. So PR is open on GitHub. The webhook comes into the application. We're going to extract details out of it. Let's analyze the PR, and based on the analysis, determine, do we want to close the PR or not? Okay. If we do want to close it, then let's go ahead and generate a comment, post the comment, and then close the PR. If we decide we don't want to close the PR, then we're not going to do anything. Okay, we'll just short circuit and get out. Okay. So we've kind of got 3 different sub-agents that we need to create. Going back here, we've got the PR analyzer, we've got a comment generator, and then we're going to have the actual executor to go do things. Okay. So what I'm going to do is I'm going to take each one of those step by step and talk about, okay, how would I create this sub-agent? And then we'll talk about the Docker tooling that we're going to use, and then we'll jump into the code. Okay. So the first one I'm going to start off with here is the easiest one. Okay, just generate a comment. It doesn't need access to any tools. It doesn't need to do anything smart. It's just going to basically say, hey, I need to generate a comment that I'm going to send to this particular user. So the goal of this sub-agent, generate a comment to post on the PR while it's closing. Okay. The model can be a really simple one, and I'm really just summarizing, generating text. So I don't need a heavyweight reasoning model, anything like that. Just something pretty basic. The inputs, it's going to get basic details of the PR. Okay, what's the number? Who's the author? What's the title, description, etc. And then the output's going to be the generated comment. All right. Now, in order to do this, again, since this was an internal hackathon, I wanted to use as much of Docker's tooling as possible. Okay. For those that aren't familiar or haven't heard, we have a new tool that we launched just earlier this year called the Docker Model Runner, which provides the ability to run basically your models right next to your containers. And what the big advantage that it gives is in my compose file now, I can specify here are the models that my application are going to need, and then I can connect them to my application, and it will inject environment variables that then my app can then use to connect to that model. The Docker Model Runner exposes an OpenAI compatible API, which then makes it really easy to use a lot of the SDKs and tooling out there. If it can talk to OpenAI, it can talk to the Docker Model Runner. Okay, so with that, I know it's been a lot of slides and everything. Let's jump into code. And so we're going to build this comment generator. All right. So let me switch to VS Code. And what I'm going to do is let's first actually spend some time in the compose file and specify the models that we're going to need to use. Okay. So the first thing that I'm going to do is I'm going to specify the models key here and say, hey, I'm going to use a model here. And this particular model is going to be coming from Docker Hub. It's a Gemma 3 model, 4 billion parameters and floating 16 quantization. There's probably a whole separate talks talking about model selection and everything. But again, I don't need anything that's that has reasoning. I just need something that's pretty good. And the Gemma 3 model is pretty good here. Okay. The next change I'm going to make is basically say, hey, this particular service, my application, is going to need that model. Okay. I'm going to inject these environment variables in here. All right. Now I'm going to go ahead and run my Docker Compose up. And this will spin up my application. I'm also running it in watch mode in case you haven't seen that. What watch mode will do will watch files, in this case in my source directory, and then anytime the files change, will automatically sync them into the container at this location. So again, I can modify things on my host and it will copy those things into the container. And if I were to change like my lock file, to add or change dependencies, it would automatically rebuild the container. So again, Compose Watch is pretty awesome. All right, let's build our comment creator agent here. Now I'm using a TypeScript framework called Mastra. It's a great framework. Has a lot of really cool capabilities and whatnot too. I'm not going to spend a ton of time talking about the framework and all that kind of stuff, but the takeaways is that with these frameworks, I can create an agent and basically give it the instructions, which becomes the system prompt. And in this particular case, the system prompt is saying you're a bot that's being used to create a comment for a pull request in a repository, informing the user that the PR is going to be closed. Okay. And then here's additional background, here's instructions, here's some specifics about the comment that's going to be generated. It should be positive, shouldn't be too technical, shouldn't be critical of the author, etc. If given the name of the author, you should include it to address them, to make it more friendly, etc. So again, we put all these things in here to guide the agent on how to operate. The other big change here, just thing to call out here, is I'm creating an OpenAI client, and I'm using the environment variable that's going to be injected into the application through my Compose stack. So again, since I'm specifying I want to use the Gemma 3 model, it's going to inject the base URL that I should use using this environment variable, and then it's going to pass along the name of the model. Okay, and so you'll see here that it's going to inject the environment variable here, and I'm going to use it, and then the model name I'm going to specify here to use that environment variable. Okay. Now the last step that I have to do in order to just hook it into the Mastra framework is just connect it to the toolkit. And then what I should be able to do now One of the really cool things about Mostra, and you'll see it showing up in the log output here, is it gives you a playground. And I can go to localhost 4111. I'll zoom that in a little bit. And I can see now the agent that I've just created and what model it's going to use. And when I click on this agent, then I can see, again, there's my system prompt. I can see that this agent has no tools there. But what it allows me to do is say, hey, let's go ahead and test this thing out. So yeah, I'm going to break my rule a little bit here. I'm actually going to use the chatbot. But again, this lets me test the agent where my app later will give it the prompt. Now I can actually test and interact with it directly. So I'm going to say, hey, create a comment for the following PR. So I create the Docker file, I do the tutorial, hooray. And what this is going to do is, again, generate a comment. Okay, hey, Mike37, thanks for completing the tutorial. It's been automatically closed to help ensure the next student can do it, blah, 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 blah. Okay, so again, this is using a local model. It's using Docker Model Runner. I'm not using ChatGPT or Anthropic, or I'm not using remote models. I have no cost. It's all just local model usage at this point. Okay. All right. So step one complete. We've got our comment creator. Fairly simple one so far, but let's keep going. Okay. So the PR analyzer, this one gets a little bit more complicated because now it needs to do more stuff. Okay. This agent is going to look at the PR and detect if it appears to basically be a I did the work type of PR. Okay. I need a smarter model here because it's going to have to do some analysis. So I might want one that can do some reasoning. It's going to be able to need to do tool calling and again, I need a smarter model. Okay. My inputs, I'm going to give it details of the PR, what PR number was it, what was the owning org, and the repo name, author description, etc. And I basically want the outputs to be, hey, do you recommend this to be closed? And then I'm going to give it tools to be able to look up PR details, etc. In order to do that, I'm going to use MCP. And in case you're fairly new to agentic applications, MCP, think about it as a protocol to connect tools that have been packaged up by somebody else. So for example, I can use GitHub has an MCP server, and I can use that GitHub MCP server, and I can basically just say, hey, I'm going to add these tools to my agentic application so that I can look at PR details, et cetera. And I can basically leverage their code, but it fits into an agentic flow. Docker's created an MCP catalog that provides many of these MCP servers in container form. And so it makes it really easy for me to just say, hey, run this. And I don't have to think about, wait, is this a UVX thing? Is this NPX? Do I need Python? Do I need Node? Do I need something else? What versions of that stuff do I need? Are there other system dependencies I need installed or whatnot? With them being containerized, I can just run them without having to do all the environment setup. And I also know that when that MCP server runs, it's not going to have access to my whole file system. Okay, because the last thing I want is have an agentic application that has access to my full machine and is passing messages back and forth and everything. So again, by running these things in containers, I know that they have very limited access to things on my machine. Okay, so the MCP catalog provides a collection of servers. And then another tool that we've provided, and this is an open source tool called the MCP Gateway, which makes it easy to now run these MCP servers. And so the gateway provides it is itself an MCP server, but it will manage the life cycle of the containers. And so then I can do things like this, where I say, hey, MCP Gateway, I want you to start the DuckDuckGo server and only expose these two tools. And then I can connect it to my application, where then my application can create an MCP client to this endpoint and now have access to those tools. Okay. So we're gonna add the MCP Gateway to our application here and give it tools and also create the PR Analyzer agent. So with that, we'll jump back to VS Code. We'll go to our compose file. And so for the first thing that I'm going to do is I'm going to just go ahead and add the MCP Gateway. All right. So I'm just going to copy this. All right, and paste. You don't want to see me type all that out. But again, this is just another container that's going to run, and it's going to use the MCP Gateway container image. I'm going to specify that I want to use the GitHub official server, and that server now has over 100 tools there. which is a lot for a model to have to interpret, and it's a lot of context length that's being used. So I'm going to specify these are the only tools that I want you to expose. Okay, some of these are going to be used by the analyzer. Some of these will be used by the executor later on. So you'll see some of like the add issue comments and update pull requests. Like those will be used in the next agent. And then everything else is just the last thing I need to do here is also configure a secret. How does this thing actually connect? And what is the GitHub token that I'm going to use here? So I'm going to use the secrets mechanism that's in Docker Compose. I have a .env file that has a personal access token. I'm not going to show that to you because I don't want it compromised right now. But there's that env file has the personal access token that's going to be used by the MCP gateway injected. There's the word I'm looking for. It'll be injected into the GitHub MCP server when it starts up. Again, the gateway will manage the life cycle of all that, okay, and do that injection securely. Now, the last thing that I need to do is my model that I use for the comment generator, Gemma 3 isn't going to be able to do the reasoning and the tool calling, etc. So what I want to be able to do is use a smarter model. Okay, so I'm going to use Quinn 3 here, an 8 billion parameter Q40 quantization here, and I'm going to specify that I need a little bit more context size because this is going to go and fetch stuff. Like it just needs more space to hold memory, etc. Okay, and then the final thing that I need to do is then connect that model into the app. Okay, and I'm also going to do one more injection here to inject the environment variable for where's my MCP gateway. And again, it's just going to connect to this container. And then I just put a depends on so that my app doesn't start until my MCP gateway is healthy. Okay, so I'm going to go ahead and just restart this real quick. Okay, so we see the MCP gateway starting up. And now my app starts up since the gateway is healthy, and hurrah. All right, so now we just need to create the agent itself. Okay, so PR analyzer. And I'm going to do the same thing like I did last time. I'll just copy and paste here. Again, this system prompt now is saying, hey, you're a bot that's going to analyze a pull request for a repository and determine if it can be auto-closed or not. And then again, some more additional details of what these repositories are. Here's the instructions you should perform. Here are things to look for. Okay, big signs. We notice that a lot of folks, when they submit these PRs, they have a PR description that's missing or doesn't suggest it is actually an improvement to the tutorial. There's updated files include changes, but don't suggest improvement to the tutorial. So again, we looked at what are the common signs of PRs that can be auto-closed, and let's go ahead and kind of bake that into the prompt here. Other consideration points, here's the output that we want. Here's an example of the output, etc. We have the same OpenAI creation. We're just swapping out the different environment variables. And then the only other thing that we've got now is that our agent, we need to give it a set of tools. And I'll show, actually, we'll make this here in just a second, this get tools method. And then these tools, again, will be available to the analyzer. Okay, so let's go ahead and make our tools real quick. And what this is going to be is a MCP client that, again, is just going to connect to the MCP gateway using the environment variable and just get the list of tools from it. Okay. So from here now, last thing I need to do is just tell Master about this new agent. And then if I jump back to my browser and the framework or the playground, now I see the pull request analyzer here. Okay, hooray. And I could see, again, there's my system prompt. I can see here's all the tools that are exposed by the MCP gateway. So again, all the ones that I specified. And now let's go ahead and kick this off. I'll copy a prompt here. Say, hey, can you analyze the following pull request? Okay, so PR number 3 in this training demo org that I've got here. Take a look at it and see if you can figure out if this should be auto-closed or not. And it'll take a second to load the Quinn 3 model. But what we should see is that the first step that it will probably perform is say, hey, I need to get additional details about this PR. Okay, and so we actually see that here where it says, hey, I need to go get additional details about this pull request. And so we see the call, here's the arguments, okay, and then we see that the full request, or the full response from the MCP server, and it's the GitHub MCP servers are quite verbose. But we see here that the agent decided, hey, we shouldn't close this one because the pull request description clearly states it's adding a missing license file. Okay, so if we actually look at that PR, it's still open right now. And yep, this was PR number 3 to create a missing license file. Okay, and that's one we want to create. So let's go ahead and actually let's create a PR that we'll probably want to close. Okay, so we'll just say from Nginx, and we'll just run echo hi there to user share Nginx HTML index.html. Okay, so I'll just make a very simple website here. Again, pretend this is part of the tutorial, and we'll call this create first Docker file. Okay, we'll create a branch and the PR. And boom. Okay, so now let's tell the agent to analyze this. Okay, and that was, what did I say, 15. Okay. And now what we should see is, again, the Quinn 3 model is going to look at this and say, hey, let's go ahead and close this. But again, it's going to get additional details first, and we'll see that hey, this looks like it's just creating a Docker file. There's no description in it. It doesn't look like it's really enhancing the content or the repository itself. And so we should get a response here in just a second. Okay. It's the fun of live demos. You never quite know sometimes how long it's going to take to get a response here. But again, it's using the tools. And like I mentioned earlier, I'm using Docker Model Runner, so everything's running locally on my machine. And if I were to show you the GPU that's activity, you'd see it spiking right now as it's trying to process the pull request details, as it's creating the response. Again, it's all just local on my machine. There we go. Okay, so I'm getting a response and recommended to close, true. Okay, so, and the reason the model decided that was the PR title suggests creating a Docker file, and the author, okay, is also the repository owner. Okay, so that could have tripped it up a little bit, but it was able to, again, use the other details that we put in the prompt, say, hey, the description is missing, etc. Okay, so that's why it's important when you hear like prompt engineering, what are the instructions, what are the different things to think about when the model should be operating. Okay. All right, so our PR analyzer, great. All right, we'll jump back to our slides, and the last one, this one's pretty straightforward as well too. So this will go pretty quick. The executor, its job is really just to post the comment and close the PR, and that's pretty much it. And so again, it's going to use the set of tools that we did before. We'll give it a prompt that basically just says, hey, take the comment that was generated previously, close the PR, add the comment, etc. Okay. And this one's pretty straightforward, so we'll just go ahead and do that one. So I'm going to create the PR executor. And again, we'll see the instructions here. Here's the steps to perform. I give it some additional rules. Don't post the comment if the PR already has the comment posted on it. Don't post it more than once. I had to put that in there because sometimes the model would just be like, yeah, I want to put this on there again. And don't change any other details of the pull request, such as the title or description. Okay, just close it. This is going to use the same set of tools that I used on the MCP gateway from before. Great. And then I'll just plug that in here. We'll see the executor added. And now if I went back to my playground and look at my agents, I see the executor there. And again, I'm using that same Quinn 3 model because it needs to do a little bit of reasoning and thinking about, okay, what do I do now? Okay, what are the steps? How do I leverage tools, et cetera? Okay. So gluing it together now. Now, one of the cool projects out there because I need to listen to this webhook. There's a really cool project called sme.io that, especially for development and testing, which is what this was for a hackathon, allows me to basically register an endpoint to say, hey, in fact, let me just show you. Okay. I need to start a new channel, and it's going to give me this channel. And now I can put this as a registered webhook on my repo. And then as PRs come in, it'll just show up on the screen here. But then they also have a client library that I can plug into my code. And I will switch back to VS Code here. I can create a SME client that then will listen to a particular channel. And then when it receives the webhook, again, SME will just forward that onto this client. I can replay that webhook within my application. Okay. And so it'll send a post to my app here, where I'll parse the webhook and look at details for it. And really what I'm going to do is, look to see, is this a pull request? If so, is it the right status? I'm only going to operate on PR webhooks when the PR is being opened or reopened, and then extract details out. And then I'm going to use a Mostra workflow, which I'll show you in just a second, and basically say, hey, run through the workflow. And the workflow basically codifies this. Okay. Now, let's actually plug in the workflow. Okay. Okay. And I need one more import here. Oh yeah, let me grab the rest of these two. Okay. Oh, those are in twice. Okay, there we go. Okay. So this what it does is to kick off the workflow. Here's the state that's needed, and when it runs, first it's going to determine. Okay, again, that's going back to the side here of the car I can close. Okay, so basically perform this step. It's decided that the recommended to close was true. Then let me go ahead and run this next. I'm going to create a comment, and then that completes successfully. Then and execute the posting of the close or posting of the comment and close the PR. So again, this is the Mostra framework, but most other frameworks have some sort of mechanism to be able to do something very similar. And then I just have to tell Mostra about this. Again, the neat thing with the play and look at, I can test out our workflow here and be hooking up a but since we all working theoretically now, let's actually here I should see let me just make one here. Just I was getting that at one point. Let's see if we can get that. There's sort of rate condition going on either with my code or the MCP gateway that sometimes gets so that doesn't connect. So we'll this off one time and see if we can. All right, there's MCP gateway starting up. And then we'll see the app start. Okay. Try to just get it so that it doesn't have those errors. Okay, I don't think I saw that. Okay, all right. So let's kick it off and see what happens. So like I mentioned, I have the webhook. Why are you red there? Okay, let's just paste over everything. Okay. Now I get my error back. Okay. See if we can. because that's the wrong file. I'll just move on. Okay, I'll keep poking on it, and then I'll come back to it in a minute. Okay, but this whole process would work, and in fact, I can just show you. Let me pull up one of the previous PRs that we were able to close. So create first Docker file. Okay, hooray, I made my first Docker file, and we see that the agent, again, receives the webhook, creates determines it needs to be auto-closed, and then we'll submit add the comment, and then kick things off and close the PR for us. Now, some of the takeaways and some of the lessons learned with this, okay, because I had a lot while building out this application. Okay, there's obviously still some gaps that I didn't talk about here. I didn't talk anything about testing of how do I actually like test and validate that this thing is working as I expect it to. How do we feel confident that, hey, it's going to close the right PRs and not the other PRs? How do we have the good confidence with that? Now, some of the things that we are doing in this space to help out with that is we've, for folks that have used test containers, we're adding Docker model runner support and capability so that you can define your models and run your models as part of your integration test. How do I test and validate calls with MCP servers? Are there ways to mock those calls during testing, like integration testing, et cetera? So I don't have to actually go and create PRs and register webhooks and that kind of stuff. Like how can we simulate some of that environment so that the MCP gateway and everything can have the right data that it needs without actually having to talk to the real external services during testing. The second point here, local models can do great things, but they still have limitations. And what I mean by that is, like, I had to actually put in quite a bit of effort to figure out, actually going back to my PR executor code here, the comment must be posted only once. I had the first couple of times I ran this, it would post the comment, close the PR, and be like, yeah, that's cool. I'm going to put the comment again. And so then you look at it like, hey, we're going to close this. We closed it. Hey, we're going to close this. And it's like, wait, it just didn't quite make sense. And so, again, just by putting this one line in here, for whatever reason, that made the model realize, oh, wait, I've already done this. I shouldn't do it again, even though it has complete steps here of 1, 2, 3. So again, local models, they can do great things, but they still have limitations because they're not the big models that we're used to interacting with as well too. One of the things I'm actually doing some experimentation right now is actually around fine tuning, so that we can fine tune models so that they work more reliably locally. But again, it's a process, and I'm still very much at the beginning stages of learning many of those things as well. Okay. One of the other things I was thinking a lot about was, especially for that PR executor, recognizing that I was having trouble posting a comment, and then it's like, okay, cool, we post the comment, now let me close the PR, and then it was posting the comment again. It got me thinking about, are my tools a little too granular? And what I meant by that is, I've got a tool for posting a comment, I've got another one for closing, updating the pull request. But what if I were to have an MCP that was like, close the PR with an optional comment? And so now it's just one tool invocation. The advantage that would give me is, well, it shortened things quite a bit, because currently it's my executor is having to do another round trip with a model, which is more time. It takes longer. It's more token usage, which means more cost if I were using models that were hosted somewhere else. And again, it's more time and resource usage. And for those that are thinking, environmental impact and that kind of stuff, again, this is a pretty small thing. So if I had my own tool that would just add a comment and close PR, well, now it's just one round trip, one tool invocation. It's that much less token usage, time and resources involved there. And finally, as I was thinking about this, I've got some parts of the system that are deterministic and some parts that aren't deterministic. For example, if I'm going to analyze a PR, I don't know what types are going to be put into. So where I think it dropped off was, some of our agentic applications have deterministic behaviors, and some parts have non-deterministic behaviors or steps. And so if you build your own agentic application, think about what step is fairly deterministic. Okay, for example, my last sub agent, the executor, is pretty straightforward. I'm just going to post a comment and I'm going to close the PR. Like, why do I need an agent to walk through that flow when I could just use the GitHub APIs directly? Okay, and so if you build your own agentic applications, well, if I were to do this one again, I would that step just straight up API calls, because it would make things a lot faster and easier and again, more deterministic. And that's one of the nice things about the Mastra framework is each of the steps in the workflow, I can determine if it's going to be code execution, if it's going to use an agent or whatever else. Again, it's code. I can choose how that step runs. So again, that's one of the things to think about as you build your own agentic application. So if and actually a good question. So can you explain deterministic versus non-deterministic? What does that mean? So deterministic things are basically, if I perform this action with the same input, I'm always going to get the same output. And so I know that it's going to follow the same path. I'm going to get the same output. So for example, a lot of code, if I've got if conditions, if I give input, I'm always going to get the same output. Okay. And yeah, Ravi, right now I'm not sharing just because I think my internet connection was a little choppy. So I'm just speaking right now. Sorry. But so yeah, deterministic means I'm going to get the same output for the same input. Where non-deterministic is you may not get the same output. And especially when working with models and agentic frameworks, you're not guaranteed to get that same output. And so again, looking at each of the different steps in your workflow and determining, well, is this a step that should be deterministic, meaning I should always get the same input because I know that it should operate the same way every time, versus some things where, okay, I really do need a model here because I'm handling data that I have no idea what that input is going to be, and I need something smarter to work with it. So hopefully that makes sense. Finally, just to recap, again, event-driven agents, they're awesome. You certainly can do them, and this was an example walking through this GitHub PR analyzer. And so my challenge that I give to you is, again, think beyond the chatbot. Think about what are the other types of applications you can build. How can you automate the various processes in your day? Whether it's, hey, when I start my day, I want to run these automated tasks on a cron job and just run it at 9 o'clock every morning, or more event-driven like that we have here. As was mentioned earlier, I'll share the slides out. The last slide has several different QR codes to the source code repo for this particular project, blog post as well too. And I think I saw that being dropped in chat earlier as well. Thanks, Anand. And also links to like the MCP gateway, the Docker model runner, et cetera. So with that, we've got a couple minutes for questions here. Oh, thanks, Christopher, for the thinking my code looks elegant. Yeah, I do write a lot of TypeScript and JavaScript as well too, so I appreciate that. And so with that, thank you again, and maybe I'll try to see if I can get my camera working. Give it a shot. So I see Awa asks, is it possible to set up the exact time when the AI agent is supposed to start running? So yeah, again, it just depends on what your application is, but I could use a tool such as cron to say, at 9 o'clock every morning, run this script, and that script could then pick off, your Python code or Node code or whatever else it might be that then runs the various agents as well too. So that's one way that you can do it. If it's more webhook driven, you can have a webhook that comes in at that particular time, whatever. So there's a couple different ways that you can do that as well. All right. Suresh asked, an agent minus a model is a generic code block. What other aspects signifies an agent? Yeah, so I would pretty much define an agent as something that's using a model. So yeah, if it's not using a model, it's mostly just code at that point. A lot of agents will also use tools, but there's not I wouldn't say a hard requirement. But as we start hearing more of like agentic applications and agentic systems and whatnot, you start to have this a collection of agents where, yeah, some are using just models, like my comment generator that had some that are doing a little bit more reasoning and thinking. So like not all agents within an agentic system are going to use the same set of models, the same set of tools, et cetera. But yeah, I would pretty much say an agent would have some sort of model that it's going to be using as well too. Now, unfortunately, when I joined back, I lost all the questions that might have been in chat earlier too. So if there were questions before 9:51 p.m., I'll probably have to have somebody else pass along. Ruben asked, for this PR use case, could we also use Nathan with a AI agent and any suitable LLM? Yeah. Again, there's a lot of different ways that you could build a similar type of application, and Nathan is a fantastic tool.
There is Chuba asking, how is a watch mode different from volume mounts?
Great question. So yeah, this is a little bit more Docker and Docker Compose. So what Compose Watch is going to do is, again, watch the local file system and then based on changes, perform some action. So with Compose Watch, I can sync files. I can also say, hey, when this file changes, actually rebuild the container image and then restart the container using the new image, which I can't do with a bind mount. And you can also set up like ignore paths. Okay, I want to watch this directory, but ignore the node modules directory or stuff like that. So you can get a lot more granular than what a bind mount can give you, a volume. The other thing that I'll just mention is if you are creating an application, you have a compose file that you want to run on Windows, Windows will do the bind mount, okay? If you're using volumes, so that bind mount will work, and the file that you change on your host will also be changed in the container. But one of the limitations of the WSL environment is that the file system event notifications that actually say, hey, this file was changed, don't propagate across that bind mount. And so if you've got your app running in a container, like a React Vite server or Vite, or however you actually say it, or again, anything that's sitting there waiting for those file system events, they're never going to get them. Where with Compose Watch, it's going to actually copy that file, the file system event notification will be there and it'll work. So personally, I use Compose Watch for everything just because of a lot of those capabilities and much more granularity as well.
Cool. I think that answered the question from Adnan too.
Okay.
And then I'm gonna paste another 2 questions here.
Okay.
So it's a little hard to read, but one question from,
good.
Yeah.
So I don't know if I say your name, Farouk. Hopefully I'm saying that right. So along with the diff tool, you might have to set the rules to accept the change or reject it and train the model for these. Yeah, so I didn't do any sort of fine tuning for this particular model. You can certainly say, hey, here's a better trained model. But I found that the Gemma 3 model did pretty well. And I do, or sorry, the Quinn models that were doing the analysis. And I have seen at times in which, okay, it gets the PR details. If the description looks questionable, like it can't make the decision, then it'll actually go get the diff. And it seems to do pretty well with it. So I haven't needed to do any fine tuning yet, but that's certainly an opportunity if I need to down the future. Crazy tool metadata used to overflow the tokens and results in out of, yeah. And so that last comment. That's one of the struggles that I currently have with the GitHub MCP servers. Their tools are very verbose. And so, yeah, we've been talking with them and trying to figure out what are ways that we can help shorten that a little bit. The MCP gateway that I was showing you, that are the Docker tool in there, does have an ability to plug in interceptors to say, hey, I want to intercept these requests and actually manipulate the response a little bit. So we're exploring some things to do there to say, hey, let's not return a response that's quite as verbose. Let's make it a little bit easier to work with there. But yeah, Christopher, great great call out there. Yeah, I should use a proper version, not latest, for the gateway image. Great point there. And what he means by that is my compose file, I just was using the latest tag rather than a pinned version. So yeah, it's not quite as reproducible there. So great observation there. And we'll ask, is there a GitHub repo with this example for more detail revisiting? Yes. So that'll be in the slide deck that will go out to everybody as well. What background is necessary for this? Honestly, yeah, building agentic applications, you need to know a little bit about models, a little bit about development, et cetera. But I'd say just jump in and just start trying and just iterating and experimenting. And there's a lot of great tools out there to help write code and that kind of stuff as well too. So let's see how we do event-driven automation on this. I don't remember what this was there, so we have to qualify that a little bit, Sheik. So by manipulating the response, what I mean is the response coming back from the GitHub MCP server is basically the full JSON body that came back from the API. So by manipulating the response, we can say, well, maybe we don't want to send the full JSON object back, or maybe we want to extract details out of it and actually just make it a text block of PR title, : here's the title, description here. And so actually convert it from JSON back to text. Again, you can choose that interceptor capability is pretty flexible. So there's a lot of different things that you can do with that. Doing the executive with AI seems to be a bit overkill. Wouldn't it be easier to use AI, or junior dev wants to generate more classic? Yeah, and again, that's kind of one of the takeaways. I wanted to do this hackathon experiment with, let's do everything as an agent, and let's find out, are there times in which just because you can doesn't mean you should? And I think that's exactly one of those call outs of, hey, that executor, it's a step-by-step, should be pretty deterministic. I don't really need an AI model to tell me, hey, you should post a comment. Hey, you should close a PR, when I already know that should be the case. So I'm glad you got that. Okay. Yeah, the avalanche of slowness, definitely. Yeah, and I got Ruben's question there as well too. So Suresh, I thank you for the compliment there. Looks and mannerisms reminds me of Harrison Ford. I'm okay with that. Fantastic. Well, thank you all. Hopefully you learned something. Feel free to reach out to me on LinkedIn if you've got questions or you just want to connect, et cetera. Again, we'll make sure that the slides get out to you as well too. Hope you have a great rest of your Tuesday and more handsome, whatever. But again, hopefully you had fun here too. And again, apologies for the network disconnect there for a little bit, but I think we made it work out. So thanks all.
Thank you, Michael. Great presentation, and thank you for all the great questions. All, and yeah, like Michael said, please feel free to stay connected with Michael if you have any questions or if you want to continue any discussions. Thank you for joining us today, everyone.
Yeah, I'm happy to stick around if anybody wants to ask more questions too. So I've got a little bit of time. But. Oh, any way to have your PR analyzer be kicked off by GitHub Actions? Yeah, good question. I guess it depends on what it is that you want the action to do. Like I probably wouldn't do this particular use case with it. And here I'll also drop in the repo link here. I could have just done that in chat earlier, but so there's the repo link. But yeah, I mean, you could have a GitHub pull request. Okay, I open up a PR and do something. The thing that I would be careful of though is, I mean, those having. Well, then again, I've got that same problem. I was just thinking having a PR that's a PR web words, a PR workflow that anybody can create that then is going to kick off your models and do stuff or whatnot. Again, just depending on what models you're using, can be expensive. If you're using like, GPT models or OpenAI models or other hosted models, the runners that exist in the GitHub runners, I'm pretty sure don't have GPU access. They're not going to be able to do a lot of these. The model running itself, they're in the actual PR. So you would either have to connect to hosted models, which again is going to have a cost associated with it, or you're going to have to call out somewhere else where the app is running itself. So in this case, that's actually why we went with a webhook flow, because it allows us to decouple it a little bit, and then we don't have to worry about what are the limitations of the actual GitHub action runners and whatnot. So another question you showed SME, how would you transition that into something you can deploy? So yeah, so SME, think of it in many ways as a webhook proxy, where, okay, I'm just running this app locally on my machine. My machine doesn't have global internet access. So when GitHub wants to send the webhook, it can't send it directly to my machine because it doesn't have a direct ability to do that. I'm sure I can probably make some like Ngrok tunnels or Cloudflare tunnel, or have some way to be able to do that, and that's certainly another approach. What SME provides is, okay, it's going to be the recipient for now, and then I can basically connect to that using the SME client, and so it's acting just as that webhook proxy for me. But so if I wanted to actually deploy this, what I would do is I would actually deploy this on a machine somewhere where then that application is deployed as direct access, and then GitHub can just talk to it directly, and I can completely bypass the SME portion of that. That's really just used for kind of local development, testing, proof of concept, that kind of stuff here. Yep, great question.